Hello friends, today we are going to find the expression of pressure using the expression of dN that we have obtained from the previous unit. So for this we have to consider a number of molecules, that is N, within a particular container, and we will extract the number dN from this molecule who are having velocity in the range of v and v plus d. Now let's suppose this elemental number of molecules which are having the velocity within the range of v and v plus dv are incident on a wall having a surface area, elemental surface area ds, now suppose this is a window through which we can capture the number of molecules which are having the velocity within the range v and v plus dv. So v and then v plus dv. So we shall consider only that component of velocity which are incident normally on the surface area. So hence we can consider v cos theta, the component responsible for striking the surface, and if we consider this together, this is the window and this is the surface of the vessel. Now suppose this, if we consider this to be an elementary volume through which we can capture those molecules which are having the velocity v and v plus dv. So in time t, this length would be v cos theta del t. Okay, so we can write dN, the molecules that are having the velocity in the range v and v plus dv, and this dN is a fraction of molecules which are having velocity v and v plus dv. So dN, this fraction, is equals to dN v and v plus dv into d omega by 4 pi into the fraction of molecules which are there within this particular cylinder under consideration, v cos theta del t del s by v. Now there is another consideration where the molecules are able to strike the surface at an angle theta and are being able to reflect back with angle theta. So hence the number of molecules which are within the velocity range v and v plus d star, v and v plus dv, and are having the momentum of p, momentum that is in momentum of mv, and able to strike at an angle theta is given by dn is equals to dn is equals to dn b comma b plus db omega by 4 pi into b cos theta dt ds by not this b but the volume v into 2n v cos theta so hence we can write on integration dn v comma plus dv then we have this square then you have and we can replace this d omega by sin theta cos theta sin theta d theta d phi. So you can write sin theta cos square theta d theta d phi. So our integration 0 to pi by 2 and d phi integration will run from 0 to 2 pi, and there is other expression also is there, other definition is there, like d square, this is called mean squared velocity, v square is equals to 1 by n 0 to d max v square dn v plus 0. So evaluating this whole stuff, we can write dn is equals to, this term becomes n into d square, then you have 2n by 4 pi v, and I missed element v over here, into this evaluates to be 1 by 3 and this evaluates to be 2 pi. So these two gets cancelled, then we have n is equals to n v square. Then we have n by v into 1/3. Let us name this as tilde. Right? So n tilde n by v square n into 1/3. This is equals to n equal to number of molecules per unit volume so we have, and another stuff we missed over here was various so tilde n by there is del t is equals to 1/3 n this way, and this is the tilde n by there is del t number of molecules heating per unit area per unit time. So this definition is actually the pressure. So the expression for the pressure is equals to 1/3 in n so this is the expression of pressure as we obtained using the concept of spherical polar coordinates and using momentum, using a hypothetical cylinder while making an angle. Okay. So this is the expression of pressure that I've obtained using the above concepts, and similarly this pressure was also obtained using virial equation in the previous session that we have conducted. Thank you.